Greetings and welcome. My name is Aaron Craig, and in this video we're going to be showing you how to create this project right here. It's a fun little physics game that you're trying to stack as many blocks on one platform as you can before one of them falls off. As soon as one falls off, it's game over and you lose. We're going to do this all inside of GameMaker using the physics engine, and there will only be 10 lines of code. So I'm going to be showing you how to use the physics engines and the properties that are associated with the objects and the room more so than the code itself, because there really is very little in terms of code, but I'll also be showing you that. If you want to follow along while you're doing this, you can download the starter project, which is going to include the objects and the sprites that I've created. Nothing else is in there, nothing else has been changed, but you can grab that so you don't have to create these objects and rename them yourself. It's a little bit easier. I hope you're excited, and let's go ahead and dive right in. So first off, if you didn't know, GameMaker has a physics engine. Most games that I see do not use it because it's great for a lot of things, but it is also more intensive. You don't usually want to create a platformer or an RPG using the physics engine in GameMaker because it really does limit how many objects you can have, and it also takes a different kind of control using different functions when you're making it. So let's go ahead and explore this physics world, this physics engine right here. In your object, you have this box that says uses physics. And if this isn't checked, then you don't have to worry about physics in the slightest. But as soon as you check it, you then are going to want to open up this physics tab right here. And this might be completely new to you, and you've got a lot of new options right here. So let's go ahead and tackle what some of these do by kind of showing you by putting these objects in our room. So we have our OBJ block right here, no code whatsoever, but we have our physics enabled. So let's open up our room, place our block inside, and then I'm going to change my target from GX Games to test because I don't want to run it inside of a browser, and F5 to start it. If I do this, nothing is going to happen. That's because this object is using physics, but the room or the world actually isn't. And that's an important thing to know because one room can use physics and another can not. So if we want to use physics in a room, we need to click on our room, open up the room physics tab right here, and enable physics. And that's really it. After that, if we run our game again, this block is now going to run and kind of live on its own. So we have several options in the room. We have a gravity X, which is going to be moving the object left and right. Typically, that's going to be 0. We have a gravity Y, which is moving the object up and down, which is more typically about what you're going to want to do. And then we have this pixels to meters, which I would recommend leaving right here. It's just that GameMaker has to understand how big something is in this world. So if you have a really large room with really big sprites, you might want to change this pixels to meters. But for most average sizes of 32 to 100 pixels, you're going to want to leave it right about here. So that's the room properties. Pretty straightforward. You can increase how fast the gravity is, and if we bump this up to 25 and run this again, without changing anything else or adding any code, this is now going to fall faster. And that's about what we're going to want for this game, is the gravity Y at 25. What's really cool about the gravity is that, or not the gravity, but the physics, is that you can actually put this in any room and not in another. So if you had a game you were working on, you could easily put in a physics mini game in one room and have them play it to accomplish a goal or as a loading screen or whatever, and then jump back to your main game, which doesn't use physics. So I think this can be really useful in a lot of different places. But let's go back to our OBJ block and take a closer look at this. So we have density, restitution, collision group, linear damping, angular damping, friction, and then a few options down here, and this modify collision shape button. So It's a lot to suddenly take in because now we have to look at all of these different options. But you don't need to worry about all of them right off the bat. If you do want to read about them, click inside and press F1, and it will actually open up the default browser that you have, and it will bring up this right here. And if you scroll down, you can click on Physics Objects, and then this is going to tell you everything you need to know about physics objects, and you can read about the density, restitution, collision group, linear damping, angular damping, friction, and all of these things right here. The manual explains everything that you need to know, and I'm going to go over it really quickly right now as well. So, if you want to read up on it, go do that. It's probably going to be helpful if you want to make a more complex game, but here's what you need to know. Density is a huge math problem, a math equation, that GameMaker is basically going to say, what is the size of our object, how dense do we want it, and the smaller something is, the more dense it is, means it's going to be like a lead brick. If we make our density 10 and it's a small object like this, it means it's going to be a small, heavy object. If this was a 500 by 500 sprite and the density was 10, it would be a lot lighter weight of an object. And so GameMaker is going to calculate that for you all inside of here. For this block, we're going to set the density just to 1. This isn't going to really adjust how the object falls in the world. That's going to be the gravity that we set in the room. Instead, this is going to determine when it actually lands and hits something, how much force does it have. In the game we're making, we're going to be able to move our blocks and actually have them fall over. If we make this too dense at maybe 100, it means it's going to land like a ton of bricks and you will not be able to push it at all. It also changes how much force you actually have to apply to get this object to move inside of your world, which we're going to look at when we get to the code. Next, we have restitution. Restitution is the idea of bounciness in GameMaker. So, if we want something to be super bouncy, we put it to a higher number, and if we want it to be not bouncy, we leave it at a very low number. Now, to show you these properties, because I think that's the easiest way to understand them, let's jump over to our OBJ platform here, and let's go to the density. And the trick with moving something in your game or not moving it is how much density it has. So if you want a platform in our game that doesn't move, like in our room we want a platform that this can land on. So I'm going to drag this object in here and spread it out a little bit just to start here. If we run this right now, both of these objects would fall, assuming that physics is enabled. Right now, OBJ platform doesn't have physics enabled, so let's go ahead and tick that, and then we can run our game. Now these will both fall down, but we need a platform to stay there. It needs to be using physics, but it needs to not move. There are a couple different ways to do this, such as a sensor, but a sensor means it can't interact, and we don't want that. Instead, there's a little trick where if you just set the density of an object to 0, GameMaker will treat it as infinitely dense, meaning that it cannot move no matter what you do to it. No force is going to actually work on it. So it's going to stay right there, but our little block can actually land on it, which is exactly what we're looking for. Now we can play around with this restitution property. Let's bump this up to 10, and watch as it hits. Woo! And it's completely gone. That's more than a trampoline. Let's bring this down to something like 1. And now if it hits, you can see it has a little bit of a bounce. And it will eventually come down based on multiple properties, but that restitution is how bouncy something is. So we don't want this to have a super big restitution or a super big bounce. Instead, we're going to set this to 0.25. And when we do that, it's now going to hit and have a little bit of a bounce so that you can still push this around as it falls, but it's not going to fly off or bounce basically indefinitely. The next property is the collision group. With this, you can have objects either interact with each other as we're doing right now, So these two objects can interact without a collision event inside of their code if the collision group is 1. You can set it to 0, which means they'll only collide if there's a collision event, or you can set it to a negative number, which means that they will never collide. I haven't had a chance to really play around with collision groups, but the idea of being able to control what you can collide with makes sense. Sometimes you might want it to collide, sometimes you might not, and that's how you can control that. The next two here are both damping properties, and damping means kind of the idea to lessen over time. There's linear and angular. So these are both weird terms, and to me at least, I'm still trying to memorize what they are, but essentially linear damping means, hey, as something falls through the air, how much do you want that air, how much do you want that friction to actually slow something down? So a low number means it's not going to be slowed down much at all. Like right now, the gravity pulls on it and it works just fine. If we set this to a high number like 10, all of a sudden that friction just that's in the air slows down our object tremendously. And we don't want that in a game where we want to be able to control things, so we're actually going to set that to 0, which means that there's essentially going to be no friction in the air and it's going to fall just like the gravity pulls it down. And then angular damping is the same idea except for when it's turning. So you can apply what's called torque to rotate an object like this. And in the air, well, anywhere I guess, that it's rotating, that angular damping is what's going to eventually slow it down so it stops rotating. So when you're working with physics objects, you're actually going to apply things like a force which says, hey, push it this way, this hard, and then it starts going. And you can apply a torque to say, hey, start rotating this way, this fast. So the linear damping slows the object moving through the air. The angular damping slows it when it's rotating. And those are the two differences there. Now, we're not really going to be rotating this at all, so we can either leave this or set it at 0. I'm just going to leave it right where it is. The last one here is the friction. And this, like linear damping, occurs, but it occurs when it actually collides with an object. So if this was sliding around, it would have very low friction on it. But if it had high friction, it wouldn't be sliding around like ice. So this can be a really great way to simulate different grounds inside of your game. I'm going to put this property to 5, and you're not going to be able to see this a whole lot. It just means that when we start moving it, it's going to hit the ground, and if we try to tell it to go left or right, the friction on the ground is actually going to make it topple to the left or right, which makes a more interesting interaction, a more mechanically fun way to play the game, in my opinion. And those are all the properties that we're going to talk about right now. You don't need to worry about sensor, starting awake, or kinematic. The only other thing that we do want to talk about, we don't have to change right now, is the collision shape though. Both of our objects are boxes, which means that GameMaker is actually going to automatically apply the correct physical shape that we have right here. If you had a circle or a triangle or some other polygon or shape, you can change it from box to circle to convex shape. And GameMaker does a really good job at guessing what it is and applying the correct thing. If you had a weird polygon, you could come in here and do something like that. And you can do that, that's no problem. But if it's a box, leave it like that. If it's a circle, use the circle. The only thing you need to note is that if you come in and you go to change your sprite after it's been given a shape, such as you make it larger, so if I double the size of this and I go back to my block, you'll see now that my block, it's kind of hard to see there, here's the collision shape. It's back to the size that it was, which means that this is how it's actually going to run inside of our game, and it's going to look real weird because the collision shape is actually here, not on the entire thing. So keep that in mind. If you change the size of your shape when it already has a collision shape, you need to go back and change that. So I'm going to change this back to 32 by 64 because the size of your shapes really plays a role inside of how those physics properties work. And now I'll go back to circle, back to box, and it automatically does it for me just like that. And that's all we have to do. So now we're ready to start coding our physics world. I'm going to go ahead and put this up here a little higher. And in the room, I'm going to make this platform smaller. Okay. So now we are ready to actually code the game itself. And like I said, this is going to take 10 lines of code. So let's do this. We're going to add an event. First one is going to be create event. And we're going to create a variable called force and set it equal to 1000. Force is going to hold the number that we're actually going to be applying the force to when we move this object around. Because when you're working with a physics game, you don't typically want to just move something like you would in a platformer where you just immediately move. You want to use that physics engine to be like, hey, I pushed it and I want it to start moving and then slow down, and I want it to do these weird things that the physics simulation uses. And that's what we're going to do. So we have to apply a lot of force based on the density and the size of our object and how fast you want it to go. 1000 is a good starter number. Then we're going to use an alarm in our game, and we're going to use alarm 0, and we're going to set it to 180 to begin. The goal of this, I'll play the game one more time to show you, is that we have a block in here, and that when it hits the ground after about a second, you can no longer control it. So you can move the one that's falling, but you can't move the others. So our alarm event is going to set the block so that it can no longer move once it changes color like that. That's going to be what this alarm does. But we're going to get to that in a minute. First, let's go and add a key down left and a key down right event, because this is how we're going to actually control the block as it's falling. So let's start with the left event. We're going to use a function that you probably haven't seen before called physics apply force. And what this function does is it does apply a force at a location with the amount of force that we say. So the x position is going to be the x position on our block. The y position will be the y on our block. So we set it to the middle center, which means that the origin of your sprite will actually play a huge role. If you want to do a kind of a weird force on your object, move your origin somewhere else. It'll be a totally different play style than putting it directly in the middle. Now, we're going left, and so in this case, we actually want to apply a negative force to it. So we have our variable force, and we're setting it negative, and then we don't want to move up and down at all. Physics apply force is one of the options that you have. There's also another one called physics apply impulse. And impulse is what you would use if you are creating something like a bullet, something that you want to immediately move as soon as you push it. For this game, I want to hold it down and have it start moving more and more and more as the key is held down. Impulse would say it's immediately going to start moving that fast in that direction. So, two different ways to move an object, but they are going to act very differently. Now I'm just going to copy this, go to the key down right, and instead of a negative force, we just take away that minus sign, and now it's positive. So, going left is a negative force, going right is a positive force. Now, with those two controls, we can actually run our game, and we can actually move this object around as much as we want. And it's kind of fun. Once you're on the ground like this, you can slide, but you can't really get up at all. You can then go and fall off, and you can see that I'm holding it down, and so I can continue using the force to kind of like slide along this. And there it goes. So you can imagine there can be some pretty fun, interesting mechanics with just being able to apply a force to an object as you're moving around. So next up, let's go ahead and get the mechanic of the game working, where you have a block fall and then you create another one and you try to stack as many as you can, because we really don't need very many lines of code to do this at all. We're going to go ahead and add that alarm event, And inside of the alarm event, we're going to set the force of our object to 0, so we can no longer move the block. So the left and right keys will still trigger on this object because we're not taking that power away, but it will do nothing. Then we're going to create a new one. So we're going to create, and this is the spot where you can kind of choose. I am going to say, in our room, I want it to spawn outside of here, either on the left or on the right. That way the player has to move it. So I want to spawn a little bit higher up, and I'm going to put it right around. If I move this block here, this is the x coordinate of the block 416. And I can see that in the position here or down there. So the x coordinate, I'm going to use the function choose, and I'm going to say choose between 416, which is the one on the left, or choose between 864. So those are the two options that it has to choose when creating it for the X position. This block I want to keep in the middle, so I'm going to move that back. And then the Y coordinate, we probably want to have it be right around the same height, which is 192. So for the X coordinate, it's going to choose between one of these, and for the Y coordinate, it's always going to create it up at 192. We need to create it on the layer we want, on instances, and the object is obj block. Now that's enough to have our game basically start running. There's only one other thing I want to do right here, and that's I want to change the color. So if you see this, we can create the block, but you can't really tell which one that you can't control the ones in the middle anymore. So to alleviate that confusion, we're going to set image alpha to 0.5. What that does is it's going to make the block half transparent in its color. So the first block goes down, and as soon as you can't control it, it goes darker, to make it immediately obvious that you can no longer control them. You can still interact with them because they're physics objects, and you can do some pretty fun stuff, but you can't move them anymore. And that's the core gameplay. Now we just need to make it a final loop and give it a score. So let's go to add event. We're going to go to other, outside of room. And in here, I'm just going to show message, you lost, and I'm going to say try again. And then we're going to say game restart. So with this, when one block falls out, it's going to restart. The last thing I want to do is really just put up a score. So I'm going to add a draw event and a draw GUI. Now, I could add a variable to keep track of the score if we wanted to, but that would defeat the 10 lines of code that we're writing. Instead, I'm going to use the information we already have. The score of the game is how many blocks we have in play, and there's a function called instance number that gives us how many blocks there are. So instead of having a separate variable, let's just count how many we have. So I'm going to draw text, and I'm just going to put this at 25 and 25. It doesn't need to be anywhere else. I don't need to adjust its properties. It'll be fine. And I'm just going to call the function instance number, pass in the object I want to count, and that's going to give us the score. So F5 one more time, and now we see the score in the top left corner. It keeps track of how many blocks we have and how well we're doing. And you can adjust the difficulty of this game based on the size of that platform, based on the physics properties of these objects. This platform actually seems a little too large to me, so I might squeeze it down just a smidgen. And that's it. Now, I'm going to show you a few more things, so don't just leave yet, but that's the core gameplay loop and all the code that we're going to use inside of here. Now, the original game I showed you, and I'll bring up one more time, has a couple of really cool effects inside of it. But these aren't code, they're actually a filter and a particle. So I'm going to go ahead and show you how to do that. But I want to say thanks for watching so far, and if you enjoy this content, leave a like, subscribe, and consider donating to me on Patreon or through my website by buying something there like a course or a book. Thank you. All right, let's go over to our room on the instances layer. And down here, there's an effect type. Now, there's a ton of effect types here, and what's really cool is you can completely change the look of your game simply by giving this an effect. So one of my favorite ones on here is actually, let's see, it was the edge detect. So if we do an edge detect effect, what's really cool is if we put them in here, it gives it a totally different aesthetic, but then it also, like, when you bring them together perfectly, they like kind of mesh together and they kind of form like one block like that. And you can kind of do some really cool looking shapes, and I like that a lot. So that gives it a totally different look, which is cool. But the one we're going for is actually going to be glow. And this says in-game only, and so we can't view it in the editor here, but by adding it, we can now have a glow effect on these. And you can adjust everything about this glow effect right here. I kind of like the default look of it just like that, so I'm going to leave it. Then we just need a particle system. So I'm going to right click over here and create a particle system. And this is one of the new things that have come out recently. And what's really cool is they have a lot of built-in particle systems. So under this library option on the left, there's a preset. And if I just go over here and I just want the GM rain. And here's the default rain that they have. Now, I think that rain looks a little large and kind of a little harsh. So what I'm going to do is just make a few adjustments here. I'm going to scroll down because there is so much that you can change. I'm going to change the minimum to 60 and the maximum to 100. And you can't really see it very well because they're just alive right here, but you can scroll down and see kind of how long they live. So if you have a bigger room or you want these particles to live longer, you can change the life. And then I'm going to change the scale to make it more like small raindrops. So I'm going to set this to 0.5 and 0.1. So it's not super big. You can't, like, you notice it, but it's not huge. And that's okay. Then we go back into our room. We're going to drag that particle system into the room. We're going to have to create a new asset layer, which is fine. Drag this up to the top. And if you press play over here in the play animation, you can actually see this immediately, which is so cool. And now, if I drag this all the way to the left, that particle system actually continues growing with it. Now, the last change we got to make here, because I don't like it looking super windy, is we're going to want it to actually kind of fall straight down. So I'm going to return to that particle system, scroll down, and we're going to adjust the gravity to 0.4 so that it's not moving over nearly as far. And then we're going to come down with the direction. I'm going to drag the minimum over here, and I'm going to leave the maximum right about where it's at. And then I'm going to slow it down by scrolling up to the speed, and we're going to put this at 3 and 5. That way it doesn't look like a total torrential rainstorm in here. And if we go back to our room, there we go. And if we run our game, we now have a cool glow effect and a cool rain effect right there. All you really need to do is add a cool backdrop and some music, and you've got a pretty fun, playable game that you can just enjoy, show off, and really take this and tweak it and do whatever you want. There's lots of different things you could do here. I can see this being a pretty fun mini game somewhere, or even a full fun mobile game if you wanted to take it that route. I hope you enjoyed it, learned something. If you did, leave a comment, like, and subscribe, and I'll see you next time. And like I always say, keep making, keep learning, and I'll talk to you later.